Today on Quantified Software, we have Phil Sarin, got a great wealth of experience, CS undergrad, human-computer interaction grad, then consumer tech, security tech, worked at a social company, worked at a mobile consumer company, grew to being VP of engineering, then was a CTO at a marketplace, and now has moved back to being in that individual contributor role. So welcome, Phil.
Thanks. I'm excited to be here.
Yeah, excited to have you on. Is there anything else you want to talk about your background so that we can kind of understand where your experience is coming from and sort of anchor on what you've seen?
Yeah. So as you said, I started as an individual contributor, and I'm an individual contributor again. And in between I did a stint in management. And so like my perspective, I took that stint reluctantly, and my perspective on management was like, how can I be a manager while doing as little management as I possibly can? And so I kind of picked up some techniques to manage a software team while doing relatively small amount of the things that felt like management, and ironically, that probably made me better at it. So yeah, that's my take. That's my back.
That's an interesting statement about management, that trying to do it less made you better at doing it. So maybe that's for another interview that we can delve into that. One of the perennial questions in software is how you choose, how you prioritize what the next piece of work is. So given your experiences, how have you seen that priority function work, and what have you thought worked well? Maybe what also didn't work well.
Yeah, I have tried several things. I have tried just complete gut feeling by the people in charge. I've tried like the spreadsheet where we kind of try to rank each thing on a bunch of axes, and we weight those things, and we stack them on a list. Where I have landed is that I don't know of a formula for prioritization. I know that we're a lot better at it when we're able to talk specifically about, like, get as close to ground truth as we can. Talk about specific things that real people are saying or doing or experiencing. Talk about potentially specific metrics that point to those things, but getting as unabstract and as real as possible. Those are the conditions under which I think, like, no matter what your priority methodology is, it's probably more likely to be true, more likely to be correct.
So what sort of metrics have you seen be useful? You said get to ground truth and to have a sort of a shared understanding of what metrics point to what to build next. But what have you seen as metrics that are useful in that priority function?
I don't have a great answer for you on, because it does depend on the business that you're in. When I was the CTO of a marketplace business, we were trying to build the marketplace, and so the metrics that we were trying to create didn't exist yet. And so we could go and look and say, well, what kind of purchasing behavior are we seeing? What kind of reordering behavior are we seeing? We did those things. What does our churn rate look like? How active are customers? We tried to reason about how individual features would affect those metrics. But the things we were building were changing the assumptions under which the metrics were calculated. And so, the thing that worked best was, hey, we're going to go and talk to the people who are using this and understand like, what are the things in the active office metric or the gross merchandise volume metric that are getting abstracted away from us that we're not seeing.
So I'm hearing a few things there which I think are interesting. One is something about metrics that are relevant to the business. Somehow, like the metrics you would use to model the business that you're talking about there, of like those marketplace metrics are critical to everybody's understanding of the business, not just maybe the engineering team's understanding of what is good and bad with a particular group.
Yes, that's right. And when you mentioned the consumer mobile company, that was a game changer, a baseball and softball scorekeeping application. Like, we did a lot of work to understand, like, okay, well, if somebody scores 5 games, that is a pretty good proxy for how long are they going to, are they going to ultimately be a positive contributor to this marketplace? Like, are they ultimately going to be, consistently scoring? Like we looked at what the drop off was after 1 game, after 2 games, after 3 games, after 4 games, after 5 games. It was like, all right, the drop off's like, stable enough that like we can look at this thing and say like, yeah, we think if we get someone to that point, then lots of other good behaviors will emerge.
Yeah, the other piece I heard you talking about is getting feedback from customers so that you don't just get information lost in the raw stats with summarization of the stats. How did you go about getting feedback from customers in a way that was clear enough on what to build, but maybe not getting lost in the specifics of maybe what one customer said or what one customer had a frustration with? How did you balance that specificity versus generality?
I think the thing that I've learned about specificity versus generality is, and there's a book called How to Measure Anything that actually quantifies this. You don't need a really big sample size to know generally what direction you're going in. So if you talk to 10 customers and if they all have the same burning problem, then odds are a substantial portion of 100 customers, 1,000 customers, 10,000 customers, 1,000,000 customers are going to have the same problem. And so I'm not scared of taking small samples if what I'm getting out of those samples is like a really clear signal for that small sample of customers. I think the thing that often happens, and I've been guilty of this, I think everyone has been guilty of this at some point, is you're under a lot of pressure to make your business work. You take a sample of like 5 or 10 customers, you get some kind of wishy-washy points, and you talk yourself up to saying like, oh no, that's a real thing. I think like when you're doing that, and I think if you've done it before, you're less likely to do it again. I think a strong, consistent signal from a small sample is a really good sign that there's something there.
Mm-hmm. Mm-hmm. Yeah, I was laughing in businesses that have more like 100 customers or, maybe 150 customers, maybe you only need to sample 3 of them. And then if you get a high signal, you kind of already know, like, so yeah. And your point is well taken as well of like, if you have a strong prior, it could lead you astray, but also might mean that you need fewer samples. And so trusting your gut on that piece is an interesting balance point.
And
so
sometimes you have like layers of metrics or layers of data, right? I can think of a case where when I was working at the baseball company, I went and I scored 4 baseball games in a row and I ran into the same problem in every game. What gave me confidence that it wasn't just my problem was that I also worked on customer support cases, and I'd seen that thing happen dozens of times, but I had no idea why it was happening. And beyond that, like we could look in our systems and see a certain data corruption problem that my issue / the customer service issue called, and we could quantify that. We couldn't make any sense out of it. But like the layering of, I hit this problem 4 times out of 4, plus we have this weaker or this more diffuse signal in customer service, plus this even more diffuse data quality signal. You can kind of like put those things together and say, oh, wait, there's like, there's something actually going on here.
Another piece you mentioned on the how you decide what to build and priority was around discovery and kind of finding your business metrics. So how have you seen companies reason about their reduction in uncertainty as they're, that they have a hypothesis, and part of what they're trying to do in building some feature is to prove or disprove that hypothesis and understand if the assumptions about the business are true. And so using product development or using engineering as a discovery mechanism for customer demand or for the business assumptions in general. How have you seen that work well or fail?
Yeah, well, I think you pointed to, you used a key term there, which is reduction of uncertainty. Ideally, what you're doing in a highly uncertain phase of a company is you're buying a bunch of options. You're like really cheaply buying options that have like asymmetric upside and known downside, which is the cost of the option. So you're running experiments, you're building little features, you're using each of these little known cost things, and one of them potentially blows up and everything goes great. It doesn't really work that way though. or it does work that way. But I think the problem, I mean, using that option framework, I think the problem with it is that anything that involves building production software is still a pretty expensive option. And so if you're gonna find your way to product market fit and glory and success as a company by running the sequence of experiments, it's like, well, the cheaper you can make your experiments, the more of them you can run. And the more of them you can run, the more chance you have of hitting it big. And if the only tool in your toolbox is we're going to build production software, then good luck. Like you're suddenly cutting down the scope or the number of experiments. You're cutting down your capacity to run these experiments to buy these options. What I like to see and what I'd like to do is talk to a lot of users. It's a little bit non-scientific, but initially you can vet a lot of hypotheses. You can spend a lot of these options in conversation where they were super, super, super cheap. You can do prototyping, and we did this at Game Changer, the baseball company, where we realized where we made the mistake once of testing a hypothesis by a multi-month production software build. And then we said, wait, and that hypothesis failed. And we said, okay, the next time we're going to do this, we're going to iterate, every few days and every week. And the way we can do that is not touch our production system. Like we can build enough that we can reduce uncertainty about what we think we need to do, throw it away, don't worry about whether it scales, don't worry about data quality or even retaining data. Can we tighten the cost of this? Can we lower the cost of this option so we can buy more of them? So that's another thing I've done. I think the thing I've seen fail a lot with this approach is ultimately what you're trying to do is you're trying to reduce uncertainty, and to do that, whenever you run an experiment, you want to be experimenting with something important. Do the results even matter? And then you want to experiment with something where the experiment actually reduces your uncertainty. And I think a tempting thing to do under pressure is to hand wave that part and to say, well, thinking of an example from the marketplace, hey, if we could address this new customer segment, it would be really great. Okay, well, that's really important. How do you lower the uncertainty around, can we address this new market segment? Well, what we ended up doing was we ended up distorting that problem to be, can we deliver a product that segment could use? Can we make the product exist? Yeah, we can make the product exist, but the reduction of uncertainty was tiny there. The real risk was well, are they going to want to buy it? Are we going to know how to sell to them? And that was well, we don't know how to do that, but we know how to do this. So let's go do this instead. So
that's find those customers. Can they learn about our software, and will they pay us a price that makes it worth all the cost of finding them and teaching them about our system? Yeah,
exactly. And there's obviously a bit of a chicken and egg question about well, how do you do that without actually having the thing? I think you can do that without having the thing. I think, as you said, finding those people, creating those relationships with them is a lot of work, and it's often happens without the full-fledged solution existing.
Mm-hmm, mm-hmm. And so it sounds like you've gone through that process of using different tools in your tool bag of building maybe not production-ready software, more proofs of concept or MVPs, smaller, maybe throwaway. But you get one of those, and like you say, it's buying an option. So you buy an option, and that option suddenly becomes very profitable, right? It goes into the money, not something that you want. How have you seen that get transitioned into production software well? It seems like oftentimes the resistance I've seen on different engineering teams is they'll get burned with doing that once or twice, or even the core product maybe existed as a proof of concept that then, gets a lot of traction. And then, the engineers are complaining that there's technical debt everywhere and they can't manage the system. And if we had only done it right the first time. So have you seen that sort of trajectory, or have you found ways to avoid that kind of common trope in software?
Yeah, I remember feeling that myself as an engineer before I'd been through this, before I'd run engineering teams. I remember like working on a code base and being like, oh my gosh, like, does anyone here know what they're doing? Um, my, the startups that I've managed in, uh, the teams were pretty battle hardened. And so, when they could tell, I think most engineers could tell the difference between something people really want and some people don't really, some people really, really don't want. And so in my last company, like there was um, a part of the product that was initially kind of an appendage. It was actually an acquired product, and we started to see that that thing had more traction than the core. And so we had to go and we had to go and like integrate those things, and um, which is messy, right? You have like two different databases, two different auth systems. You know, you for a while two different front ends that we kind of had to hide. We had to like make it look like they were the same front end, but they were actually different. And it was gross, but it wasn't a morale issue. And I think it wasn't a morale issue because, we had people who'd been slaving away for like 3 years and trying a bunch of stuff on the core, and they all kind of knew it wasn't working. And when they saw something that was working, they were like, yeah, okay, yeah, we like stuff that works. We'll take some debt and write some dirty code to get, you know, to make this thing successful.
Team maturity as a way of kind of seeing all the failures to then really appreciate the fact that you've got something that customers want and they're buying and they're moving forward. So on that team point, have you seen companies effectively be able to measure either individual contributors or team output?
I think that's a really fascinating and hard topic. So on the individual level, I have not figured out a way of quantifying individual performance. In terms of team performance and like group output, like this is the thing that I've thought about a lot. I'm a fan of a book which I think you read called Principles of Product Development Flow, that like kind of riffs on this topic of like, well, how do you like quantify the output of a product development team? Like the basic thesis of this book is like, you're doing it wrong. It's Principles of Product Development Flow by Donald Reinertson.
Yeah, which is an amazing book, and he probably says that you're doing it wrong every chapter. And the book is 175 principles of product development, where I think any 10 of which could be a book on their own. Like I think this could be a 17-part volume that is still very dense. So even just in the single book form, it's incredibly dense. And incredibly mind expanding. But so yes, I want to hear your analysis of his, in this part where he says how you're doing it wrong.
Extremely dense is the right way of talking about it. Probably like the main point he makes in the book is that the reason we're doing it wrong is that we're ignoring a really important variable when it comes to measuring team performance. And that important variable is something that he calls cost of delay. And the way you can think about that is, let's say you're trying to build a feature and you've got a schedule A, which would have it built in 2 weeks, and schedule B, which would have it built in 4 weeks. Let's assume these are accurate, which of course they're not. But the theoretical difference between schedule A and schedule B is that you're taking there's a 2-week delay that you're taking. And so the question is, well, how much money are you losing by that 2-week delay? And, his take is, well, hey, when every time we're building a feature or every time we're thinking about doing a thing, we're asking, how much does this cost if this ships a day later or a week later or a month later? And that completely transforms how we do prioritization. And it completely transforms how we look at performance. To kind of contrast that, or to say like kind of how does that get practical or how does it matter? I mean, And the way I like to think about it, the way that eventually made sense to me is if you view your software development team as this road that goes 100 miles, like an 8-lane highway, that's like 100 miles long, and features are the cars that kind of get on mile 0 and they drive all the way to mile 100. We're very comfortable at thinking about the cost of capacity. Like, oh wow, this road cost us this much to build, and so we don't want there to be like empty spots of asphalt on this road because it feels like we're not using our capacity enough. We're really comfortable even like sitting at the end with a stopwatch and saying like, counting the cars that go by and saying, okay, these many cars per minute are going through. So we've got really good throughput. So we're comfortable with measuring utilization. We're comfortable with measuring throughput. But the thing that this book like points out is we're not comfortable at measuring cost of delay. And the way to think about cost of delay is like, well, let's say you have this golden car that's holding like life-saving supplies that's at mile 0. And every minute that it's not at mile 100, like you're paying extraordinary, like, I was gonna say unquantifiable, but this is quantified software, like really, really big costs by not having this car, you know, at the end. Well, the metric there that matters is not, it's not throughput, it's not utilization, it's cycle time. It's like, well, how long does it take from this car to drive from here to here? And there's a relationship between throughput and between cycle time. Like if there were no cars on the road, your cycle time would be wonderful, but it would obviously be, you would obviously not have a productive development team if you did nothing except what someone said, okay, now it matters, show it work. If you had a road that was full of cars, even if you had good throughput, your golden car could just never make its way through. Like it would take forever. So finding this balance between throughput and cycle time, finding, you know, essentially how are you balancing your cost of delay, you know, the amount of money you're losing by this car not being at its destination, and your cost of capacity, the amount you're paying for this road. Like those trade-offs are the kinds of things that this book wrestles with. My takeaway was like, it pays to spend a lot of time thinking about, measuring, emphasizing, talking about your cycle time with your team. Because generally the money that you're losing by not having stuff in customers' hands, in most cases, not always, but in most cases, like dominates how much you're paying your dev team.
Yeah, which is very hard, I have found practically to implement because I'm paying for capacity in these green things that are made out of paper that I can feel and touch and have president's faces on them. And I like understand that that is money, and that cost of delay I'm paying in some amorphous opportunity. Similar to that options description you were having for features, I'm paying in lost options upside, which is very hard, I think, for most people to reason about.
It's completely apples and oranges. You're right. I mean, in theory, it's money is money, but in reality, you have a limited supply of those green things because you probably have a burn rate, or you have a runway, and you can see the end of your runway coming, and so that's very easy to quantify, very easy to value. And well, this cost of delay, it's like, well, sometimes maybe it's actual real money. Like sometimes maybe you're running the kind of company where you build these things and your cash flow will immediately turn around and your runway will get longer. But most companies are, I would say, most startups right now, practically all venture funded startups, that they don't work that way. And so you have to go and compare like, well, you know, what is the value of uncertainty production, you know, in terms of cost of delay versus like the money that pays for my cost of capacity. I don't have a enlightened principle on that. I feel like I get in fights about that all the time, and those are really important fights to have.
Mm-hmm. Mm-hmm. One of the other big takeaways, or the things that struck me in reading about cost of delay in products, principles of product development flow, was that as an engineer managing computer systems, I've kind of understood this queuing theory issue of that if you start to run a server past about 80%, and it's not a perfect number, but roughly 80% utilization, your queuing time on any particular piece of work that's going to be submitted to that server is going to increase, and it'll increase to infinity. If you're at 100% capacity, if you have any variation in the arrival rate of your work, your queue time is just going to continue to trend upward, and like eventually, you know, you're gonna find the boundary of infinity. Unless you have some other way to reduce the amount of work, your queue time. So in the product development realm, you are gonna, if you are running your dev team at 100% utilization, your queue time for any item is just massive. It's going to be dominated, or any service time is going to be dominated by the queue time. You know, 99% of the time will be spent waiting. And that, again, emotionally, I have a hard time thinking through and advocating for that we should set a utilization rate on any of our software engineers or anybody in the product development process at 80% as a way to minimize the queuing time and to minimize the cycle time. I don't know if you've even gotten into that conversation with anybody.
Yeah, I have. I mean, I think there's some self-delusion necessary to do that. You know, I think Kanban kind of can help with some of that self-delusion, right? There's this idea of limiting work in progress. What limiting work in progress does, limiting the number of cars on your highway, you're essentially artificially depressing your utilization. And it works. You can get things through more quickly. Well, what do your developers do if, you know, you're limited work in progress and you're saying, oh, you can't pick up another thing? I think like the thing is, like, once you get used to it, well, there's a lot you can do. Like, one is you can go and help someone get a thing done. You know, maybe you can test a thing that needs to get tested. Maybe you refactor a thing that wouldn't otherwise get refactored, or otherwise like kind of do that kind of, you know, investment / tech pay down that, you know, might be optional. Maybe what I find is in practice, you're just giving people a little bit more autonomy on like, well, how can I be valuable when there isn't a gun to my head? And that tends to return. I was able to convince people that it worked by showing the before and after. You know, I came into a team where the Trello board was like multiple pages. It was like all, you know, completely full of cards. The road was completely full of cards, so to speak. And I just said, hey, we're not going to do that. We're going to get, we're going to do a small number of things at a time, and we're going to get them done before we start other things. And it worked. You know, we started.
You're skipping through. You're skipping over a montage piece in the movie when. So you have the original decision. You declare it to the company. I feel like you're skipping the 2 weeks, maybe a month of really pushing and kind of holding that line with all the stakeholders or convincing them or something. Like, how did that process work of saying, this is broken and we need to change it, and here I know what it is we need to change?
Yeah.
That process through to kind of getting the people that you had to convince also bought in of like, you know what, you were right, that was the right thing, we are in a better place. Talk us through that gap. That's a fascinating.
Both times I've done it, I had an advantage, which is I was a new engineering leader and at the company. When you bring in a new engineering leader, part of the reason you do it is because your state of mind is like, man, I don't know, like, we got to do something. And this Phil guy is saying we're going to do less stuff and we'll deliver more. That seems crazy, but like, what do we know? So there's like, you know, there's that where you have a certain amount of like new guy cred that you can, you know, that you can use to do something, and it'll work. But I did have, I remember like having conversations with like a VP at the company, you know, where I was explaining like, I don't really know how to reach some better capacity. I have these people allocated on this problem. I'm not quite sure what features we're going to build and when we're going to see them. But I'm pretty confident that this is going to, like, you know, that we will get something good. And his response to me is like, what are you going to deliver and when? And I'm like, and he wasn't being a jerk about it. It was just like, like, when are you going to deliver something that matters? And I'm like, you know, cut me some slack. Fortunately, within about 2 weeks, we were delivering faster than we'd ever delivered before.
And when you say faster, just to be really specific about it, you're saying your cycle time was faster than it ever was.
Our cycle time was faster. We got something out to customers, we got feedback, we tuned it, we did it again, we did it again, we did it again. And so the externally perceived rate of improvement was really high. And, possibly I got lucky that time. I mean, I had a really, really committed engineer who like just literally went to a bar, wrote like the first line of code, curled his own JSON API, slacked the results to an operations team, and used that to tune it until like we saw that it was working and could like build other stuff on top of it. But yeah, I mean, I used new guy stuff, and I relied on and lied and maybe got bailed out by a team that was excited to work that way. And that like, maybe I got lucky twice, but like in both cases, like within a couple of weeks of like people kind of giving me the benefit of the doubt, like I was able to point to something.
And you pitched it. Did you use the same highway analogy? I think it's very concrete and kind of understandable to anybody. I can visualize cars on a highway. It's easy to understand. We all understand the concept of getting stuck in traffic, and maybe that's not the best way to run a highway is to have more cars than could go on it. Was that critical to being able to explain these techniques, or why you cared about this particular metric?
I think it helped. I gave a talk to the company, but then yeah, I had a conversation with that VP where everyone's like, yeah, your theory sounds great, but all right, like really, my team's gonna fall over if you don't build this. So I could set that context, but then it's management, you have to repeat yourself. So I had to have the conversation in concrete with that person. I had another manager who was another non-technical manager who worked with an engineering team and was like, wait, why do you have multiple people working on the same thing? And yeah, like we literally sat in a room for 2 hours and talked about utilization, cycle time, throughput. Got down to first principles of why we're doing this, and he was like, all right, I'm gonna give it a shot.
Do you think that you convinced him, or do you think you just wore him out, or do you think that you established to that person that you had enough confidence and conviction and thinking and theory behind what you were doing, that it wasn't just kind of shooting from the hip? Phil's got some crazy idea.
Yeah, it was the last thing. It was like, okay, like there's a lot of thought that's gone into this, and so I'm going to give it a shot, as opposed to like, oh, Phil prefers having multiple people work on stuff. Well, with no context on that sounds kind of crazy.
Yeah. Well, why do you want tea instead of coffee? Like, isn't coffee just as good, right? Like,
yeah.
Yeah. Thinking through, like, I don't know if I would have had the willingness earlier in my career to sit through and really work on a 2-hour meeting and have that focus. And maybe that's why I've not been as effective in.
This came back to like the flip comment that I made at the beginning. Like, obviously you have to work really hard at management to be good at it. And I'm not diminishing the craft by I didn't mean to diminish the craft by what I was saying, but what I did mean to say is like, hey, if my team is working on 10 things at once and I don't want to be managing to begin with, that sucks for me, because all I'm doing is checking status on 10 things all the time. If my team is working on 2 things and those 2 things are getting done a lot, I'm getting asked for less status and I have fewer things to manage. And so like this fit my temperament, this fit how I wanted to spend my time. But it also, I saw 2 different engineering teams improve their output by focusing on cycle time rather than improved their output in terms of ability to deliver features to customers in time, but also in terms of their standing in the organization by thinking more about cycle time than about utilization or throughput.
Mm-hmm, mm-hmm. So another hard to measure aspect in software is quality. How good is the software? How applicable to the use case is it? And kind of the flip side of that coin, we've touched on it a little bit in this conversation, is technical debt. And so how have you seen principles of product development flow kind of interact, and what does it have to say on the concept of technical debt and generally quality, applicability to purpose, those types of measures and metrics?
I think the application of the book to technical debt comes back to cycle time. And there is there is some discussion about like different kinds of testing and, the granularity of which you should do testing. I imagine you've seen the technical debt means a million different things, and some of them don't really mean a lot. It's an imperfect analogy because you can take technical debt and never, ever, ever pay interest on it. And so it's not really debt, and you should never pay it down because there's no interest rate. And so sometimes like I would be fighting my own team on this, where they'd be like, yeah, this is really ugly. And I'm like, yep, cool, doesn't matter, great, let's move on. But the kinds of debt projects that I would be like very aggressive about taking on were the ones where, there's the stuff that directly maps to a feature. And that's like no one even considers that technical debt. Like, hey, we need to build this thing. In order to do that, we need to clean up this other thing. Like, that's an easy conversation. I think the harder conversation, but the one that I like continually walked into was, can we work on a thing that sustainably improves our cycle time? Like, is there something we can do where we could have, we can build this thing and then the time it takes to build everything else, like, gets smaller. I love to do that stuff. I got in fights every single time I did it. First time I did it at Q at the marketplace was, I took our best front end developer had we were about to hire a bunch of people, or we had been hiring a bunch of people, and we were starting to accelerate development of this marketplace. And the our best front end developer came in and she was like, hey, I can do this. Like, I know how to get this team moving quicker. Like, we need to build these components so that so that like relatively new, relatively inexperienced front end developers can move faster. I pulled her off of feature development, had her work on that for 2 or 3 months, and the cost of her not building features was that everyone else was building features faster because they were using the stuff that she built. I've done things like GraphQL migrations, TypeScript migrations, and like what I could trace it down to was, with an effort of 1 or 2 developers for a couple of months, like 20, 30 people can be writing software more quickly. 20, 30 people can be, can be iterating more quickly. We can build our mobile app. The time on building our mobile app goes from 6 months to 3 months. I love taking on those kinds of debt projects. They are directly attack cycle time. They directly make you increase the output of your team permanently. And they are really hard to fight for. And I've gotten in a lot of fights on them, but I think that I don't have 100% hit rate on those, but like a pretty good hit rate.
When you say that they're hard to fight for and that they're, controversial, or that it doesn't seem like they're getting prioritized, is it because you think that other people in the business are not seeing the value of it, or that they have a different value curve for cost of delay, or like fundamentally, where is the disagreement there that you have? Do they not believe the estimations, or do they have a different assumption that is different from you?
I think it arises from a good thing, which is that there is nothing that demonstrates value like, stuff that's working and stuff that can be sold. I mean, that's fundamentally the idea behind cost of delay is things are valuable if they can be sold. If we're delaying the amount of time that something can be sold, then that would, that stinks. That's not good. So I think like that's where it comes from. So I'm making an indirect cost of delay investment by saying I'm going to take one person off of building software. So I'm taking a feature from not the bottom of our priority stack, but the bottom of the priority stack that the development team would be working on. I'm incurring delay for that, but in turn, I'm making it so that other things happen faster. I think that is I mean, I think like there should be a fight about that. Like, I don't think the people who are fighting with me are idiots. Like, I think they're like, wait, you are kind of doing the opposite thing of technical debt. You're incurring some delay now so that we get a lot less delay in the future. Whether that argument gets won or lost, it depends on like how much delay am I incurring now, how many developers am I using now, and how much delay am I taking off in the future. When I can point to like, yeah, our mobile app, which does not exist today, which needs to exist soon, a whole lot like happens a whole lot more quickly if we do a GraphQL migration, you know, then it still feels a little weird to people, but it's like, okay, yeah, I mean, like, am I going to tell the engineers that like they don't know how to build a mobile app? You know, ultimately there's, you know, ultimately they need to, you know, they need to trust my estimation, but I think it's the indirectness that is, that I think rightly is concerning.
Yeah, oftentimes in a technical debt conversation, I've seen it phrased as, you know, the feature to build is well known, and there's kind of two paths to get there. Usually there's never only two paths, but in the, you know, the standard model, there's two paths, and one is shorter and you get to ship it sooner, but there's some ongoing cost with it, or there's some, oh, it'll be harder to change or upgrade later, or it increases some backlog of refactoring that will need to be undertaken in the future. Oh, when we do migrate to GraphQL, it's going to make the project bigger because we're building one more piece that's not on the new GraphQL endpoint, versus we could do a longer project, incur more delay, but quote, build it right. And I feel like, though, at least in my career, those have been the more emotional, internal to the engineering team discussions about technical debt. So, and oftentimes in the, you know, using principles of product development flow and cost of delay, I would say, and my general sense in startups is like, well, let's just ship it now. We don't know if we're going to throw this thing away or not. So let's not spend more time building it than we absolutely have to. And what we buy is we buy the option to come back and go and do that more work later. But oftentimes not emotionally satisfying answer.
In my experience, that's usually the right thing to do. But the kinds of questions I ask in those conversations are around, well, you know, hey, what else, like, what do we know we need to do? Do we know we need to do it? If it's like, well, we could clean this up and this might be useful when we do this. It's like, well, doing that is a thing we don't even know we need to do. So let's not worry about that.
We might need to do that. We could do this. Yeah.
But if it's the, we absolutely have to do this, and we could get subpart A done a little bit more quickly if we delay subpart B, both of which absolutely need to get done, that's where I get unafraid to say, all right, we're going to introduce subpart C that might delay A a little bit, but we'll get like, you know, we'll, over the course of this stuff that must be done, we'll get it happening, happening more quickly. But yeah, like ultimately there's like a so what conversation here. It's like, all right, yeah, this, you know, the user model's ugly. So what? Well, it's ugly. Okay, yeah, cool. I've seen ugly software before. The world runs on ugly software. That's fine. It's like the user model's ugly. So what? Well, we're not going to be able to do this integration. Okay, that's a problem. Well, okay, well, how can we hack this integration so we can do that? Well, our business strategy depends on our rolling out 5 integrations a quarter, and we've got these committed to customers, and we expect we're going to have these committed later. And it's like, okay, now you're making, like, now your argument's getting better and better and better. But it's like, you got to have that so what conversation.
I like that. I like that. The so what, or the like, it's ugly and like, and I like that. That's a good heuristic. This has always been, it's always been great chatting with you about software and measurement and principles of product development flow, cost of delay. My head is always feels like it's expanding when I'm chatting with you, and want to jump back in and try some of these things. So thank you. Is there anything else you want to add, or any other questions you want to delve into?
No, thank you. Thanks for the opportunity to come on. I enjoyed the show, and enjoy our conversations as well.